Do you know about diode components? When you think of a standard diode, you probably imagine this symbol and component. Actually, there isn't just one type of diode, but many. In this video, we will explore the characteristics and operating principles of 4 out of 6 common diodes. I have left a link to the video about general diodes in the comments. First is the general diode. The symbol looks like this. Diodes have a characteristic of allowing current to flow in only one direction. This is related to the structure of diode. The diode consists of a junction between a p-type silicon and n-type silicon. If you look closely, the depletion layer exists between the p-type and n-type silicons. When the current flows in the forward direction, the depletion layer between the p-type and n-type narrows, allowing current to flow easily. When current flows in the reverse direction, the depletion layer between the p-type and n-type widens, preventing current from flowing. This is the principle that allows a diode to conduct current in only one direction. However, problems like voltage drop occur. For example, if you input 5V, the output voltage after passing through the diodes might become 4.3V. Why does this problem happen? We call this forward voltage drop. Think of it as a sort of toll fee. The forward voltage drop of a general diode is about 0.7V. A related term is average forward current. It refers to the continuous current the diode can handle. Now that we know the forward voltage, let's look at the reverse voltage. It refers to the voltage limit the diode can block when current attempts to flow in reverse. We call this breakdown voltage. If a reverse voltage higher than this is applied, the diode will be damaged. These are the characteristics of general diode. This is the symbol for a Varactor Diode. The characteristic of a Varactor Diode is variable capacitance. Simply put, it looks like a capacitor has been added to a diode. The capacitance is determined by the size of the depletion layer between the p-n junction mentioned earlier. The higher the reverse voltage applied, the larger the depletion layer becomes, causing the capacitance to decrease. If we look at the graph, the size of the depletion layer and the capacitance can be shown as being inversely proportional. If applied to an LC circuit, it feels like adding a variable capacitor. Next is tunnel diode, which might be a bit unfamiliar. If the depletion layer gap over general p-n junction is 1, this guy has reduced it to about 0.1. While current in a general diode jumps off the depletion layer, in the tunnel diode, it pierces through the depletion layer. It's a type of quantum tunneling. Here are the terms used. IP and VP mean peak current and peak voltage. IV and VV mean valley current and valley voltage. VFP stands for projected peak voltage. Let's look at these terms along with a graph. It can be represented by an N-shaped graph. The input voltage starts at VP. At this point, the current passes range is at its maximum, so the diode operates normally. Then the input voltage changes to VV. At this point, the current passes range is at its minimum, so the diode doesn't operate well. Does not operate well. This is the point where it defines Ohm's law. We call this section the negative resistance region. If we increase the voltage further, we reach the VFP region. From this point on, the current can flow freely again. The characteristic of a tunnel diode is that it turns the diode function on and off according to the voltage in the low voltage range. Finally, the Schottky Diode. It doesn't look much different from a general diode, but there is a difference in the junction structure. As mentioned earlier, the junction structure of a general diode is p-type and n-type. However, the Schottky Diode's p-type junction is made of metal. The advantage is that it can lower the forward voltage, which is like toll fee. Comparing them, the advantage is that the VF of Schottky Diode is around 0.3V, reducing the burden of voltage loss. Why is that? The reason lies in the junction. The general diode consists of p-type and n-type silicons and a non-conductive depletion layer. The depletion layer can be compared to a barrier that electrons must cross when moving from p-type to n-type. In a general diode, this potential barrier is high, so you need to spend about 0.7 volts to cross it. However, since the Schottky diode has a depletion layer between metal and the n-type, in this video, we briefly look at 4 types of diodes together. Next time, I will upload explaining the difference between LEDs and photodiodes. If this was helpful, please subscribe and like buttons. Thank you for watching.